let's see what happens. So here's the assignment, and I'm just going to go ahead and see if I can copy all of this. Yep, well, maybe I can copy all this. Okay, so here is scene.py. Yank that in there. Okay. A scene is a frame that uses TK interlibrary to draw a somewhat realistic outdoor scene in the frame. Right. So, init gets called when we create an object, so we don't have to call it ourselves. Oh, okay, here's what we're calling scene. Alright. Draw scene. Create oval, blah, 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 blah. Okay, so let's see if I've done this correctly. Okay, so Python, yeah, right. Scene py. Well, we got an ellipse. That's what we wanted. I'm assuming if I close that, that causes it to return. Okay, good. Well, that's a start. So a canvas is it's a TK canvas. So let's look up what we have on Python canvas. Arc, oval, polygon, rectangle, text window. We're not going to worry about all of that stuff. Add tag, no, I don't care about any of that. Turns a bounding box. I don't care about that. I was hoping to find what I could draw. Create arc? Is that what we called? Was it create arc? Create oval. Okay. So let's see if we have a create rectangle. There we go. Fill equals blue. We got create line.
Thank you. I'm gonna go see Lillian.
Well, so that should be enough to get us started. So let's try that. We wanted to do a, we're going to leave that there for the minute. So we want to do a draw sky. Sorry, I'm used to camel case. And we're going to need canvas, scene left, scene top, scene right, scene bottom. You know what? We're going to have to pass those everywhere. How do we set instance variables in a class? I would assume it is this dot left equals 0, this dot top equals 0, this dot right equals 799. Oh, and I'm putting semicolons in there, aren't I? Sorry. Too much C++. This dot bottom equals 599. And then draw scene takes a canvas, but I'm wondering if now I can do that and do that so that these get set before calling draw scene. And let's do def draw sky canvas, and my colon there, and let's just do a print canvas dot left and just see what happens there. Alright, so missing parentheses and call to print, of course that's what I meant. As you've heard me complain before, these computers are so literal. Okay. This is not defined. Oh, self, not this. Okay, so replace this with self. Doop, 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 doop. Let's try that. Canvas object has no attribute left. Well, this doesn't pass the scene object, it passes a canvas. Alright. Draw scene. So let's do that. So then we're passing in scene, and in that case we would do self.canvas, self.canvas.pack. Then I can get rid of canvas here. I can just use scene, and I pass scene like that. Alright, let's see what that does for us. Okay. So that printed out 0 as the left, which is what we wanted. So now we can say let's do see, we've got width and height here. Those should really be attributes of the scene object. So we should do def width self return self dot right minus self dot left. And so now we should be able to do a print scene dot width, right? Let's see what that does. 799. Okay, that worked right. And likewise, then we should be able to do a def height self. Why am I doing this? I'm doing this because I'm going to have to worry about width and height a lot, and I want to be able to make these attributes of the object itself instead of having to keep track of them myself. Alright, so self.top minus self.bottom, because things are backwards when you're doing Y on a screen, minus self.top. Okay. So now we can say scene.canvas dot create rectangle, and it should be scene.left. So this is going to be our sky. So we want blue rectangle top 60% of the scene. How does that sound? Alright. So we want to create a rectangle, scene.left, scene.top. Let's see. How was a rectangle done? Was it width? Create rectangle. There we go. Bounding box. Rectangle bounding box. Fill. Okay. So this should be scene.right 0.6 times scene.bottom. Fill equals blue. Let's try that and see what happens. Okay, so that looks pretty much like it filled in the top 60%. I realized just as I hit that I don't want this black line there. And if you remember back here as we were looking at this, looks like outline. Yeah. Outline equals we're going to try for none and see what happens, okay? Outline equals none. Let's see what that does. Of course, I really ought to start wrapping these a little bit. All right, let's do that. Okay, so now we say, I don't know, it still looks like it has the black line there, but it's kind of hard to tell. Yeah, it didn't complain. We'll leave it like that for a moment. So that's the sky. And again, it would make more sense to make these methods of scene rather than functions. But they said to use draw sky's function and so forth. All right, we'll try it and see what happens. So we had to have a, let's see, we needed to have sky, ground, and clouds. All right. So let's do a draw ground scene. And I shouldn't have a semicolon there. That's left over from C++. Okay. Draw ground. Def draw ground scene. This is also going to be a rectangle like that, except we want it to be the rest of the scene. And so what we ought to do here is we ought to create a constant. I don't think there are any constants in Java or in Python. So we'll say self dot sky percent equals 0.6. Okay, and the uppercase is supposed to imply that that's a constant, so I don't expect that to change. So now I can say scene dot sky percent. So now I say And this should really be, instead of scene bottom, to make this portable, this should be scene.top plus times scene.height. Okay. And why that matters is now this is scene.top plus 1 minus, no, this is scene.sky percent times scene.height, so that'll make it pick up at the same place as the last one left off. So that's left, top, right, and then this would be scene.height, I think. Did we do that right? Oh, if I make that color blue, we'll never be able to tell the difference, will we? So we'll make that brown and see what happens. Did I never exit that? I never did. It's still sitting there. All right. Okay. I don't know what that looks like to you. That doesn't look very brown to me. So let's try. So there's how you do a color, RGB. Brown is RG low. So we're going to make that pound 404000. Let's see if that looks more like brown. If you haven't done colors, that sure doesn't look like. That doesn't look like brown. Depending on what angle I look at it, it looks black. Okay, brown is a dark orange. If I did, so colors are hexadecimal notation. FF, FF, FF would be white, okay? And we can see that very quickly here. So that's the white here. Now it looks the same as when I didn't fill it in, doesn't it? So the colors are red. So that should be, yep, red down there. Green. So that gives us our green down there, which I don't really want. Blue. And so of course this should be indistinguishable from the sky. Well, except we do really have the black line there, even though I thought I tried to get rid of it. Okay. But we can see the sky and the ground. And so you mix those colors to get the colors you want, RGB. And if I do red and green, that should be orange, I think. Nope, that's yellow. I knew that. Okay, yes. Right. Sorry. If we drop the green a little, then we should start getting orange. So we'll make that 80. That's in hexadecimal, that's half of FF approximately. Okay, now we've got the orange we wanted. All right. Now, if we cut that to 40 and that to 80, now this should start looking more brown. There we go. So there's our ground that's brown. That's why it didn't work when I did it the first time. Okay. So we've got our sky and our ground, and now we want to draw clouds. Well, do I really want to draw clouds? I think I want a draw cloud, okay? And we'll see why in just a minute. This way I can then create a loop to call draw cloud several times. But let's see what draw cloud is going to look like. And I'm drawing my inspiration from this. Where did it go? There we go. You'll notice their clouds are made up of a bunch of subclouds, if you will. So I'm going to make a cloud be a bunch of ellipses of different colors close to white and gray clumped together to make a cloud. All right. So let's see. Cloud width equals, where did we get random from? Does anybody remember? Python random number generator. Yeah, I know. Random seed, random set state, rand int. Okay, so random.randint. So we want to say, oh, I don't really want a rand int though. I really want a random sample. Okay, uniform AB. That's what I want. Okay. So I need to import random. Yeah, it was random. Cloud width equals random dot uniform scene dot left, no, actually I want 0 scene dot width. Okay. Over 4. So the widest a cloud will be is a fourth of the scene width. And in fact, we can do a print cloud width just to see what we get here. And I could have gone with randint if I was going to do that, couldn't I? All right. 40 is the width of that one. All right, so we're going to get rid of that. So I could have said rand int. I'm used to a uniform being between 0 and 1. And once I realized I can put the complete range on it, I can do a rand int that way. And then, whoops. Non-integer stop for rand range. Well, excuse me. Okay, now we've got random width of 17 and cloud height equals random dot randint 0 int scene dot sky percent times scene dot height. And again, I really meant for that to be over 3, we'll say. So it can be as high as a third of the scene of the sky. Is what that does for us. And so we should be able to see cloud width and cloud height there. And sure enough, 132.54 is the width and the height of our cloud. So now what we're going to do is we're going to say n ellipses equals random dot randint 0, and we'll just say 20. So we're going to have somewhere between, actually we don't want to have a very small number, so we'll go random 10 to 20. Somewhere between 10 and 20 ellipses in our, where did it go? There. Between 10 and 20 ellipses in each of these. Okay, and we're looking for create ellipse, wasn't it? Create oval. Why do we have multiple names for these things anyway? Okay. Fill color, outline. So, all right. So now we're going to say for, and we're going to use that weird underscore. When I first saw it, it looked really strange, but I realized I kind of like it because I just want to count from 0 up to 1 less than n ellipses, and I'm not using the count, and so this is kind of a throwaway variable. Let me get rid of that for now. We're going to say color equals random dot randint. I said I wanted this to be close to white. So we're going to go from FF is 255. That's our max value. So we're going to go from 240 to 255. Okay. Why do I know these things? Powers of 2 are things that you just get very used to if you're an electrical engineer, which is what my background is. And in the olden days of programming, you had to be very familiar with powers of 2 also. It's not so important now, but for things like colors that are still done with powers of 2, it's kind of useful. So that's going to be the color of our ellipse. And this is the width of our ellipse. Oval, not ellipse. Oh well, still calling them ellipses, I guess. Equals random dot randint cloud width over 5, cloud width over 2. And of course I should make both of those ints because we've already established that randint doesn't like to have non-integer parameters. Okay, e width, e height equals random dot randint int cloud height over 5 int cloud height over 2. We'll make those kind of proportional. Ex off equals random.randint. Now I don't want it to go outside my bounding box, so it's got to be from 0 to cloud width minus e width. So if you can picture, if this is the width of my ellipse, then, yeah, it's not very good doing it in text, is it? Well, we'll see what happens here. Basically, this guarantees that it won't go past the right-hand side of this arbitrary bounding box that I've created with width and height. EY off equals random dot randint 0 comma cloud height minus e height. And now all I have to do is scene.canvas dot create oval scene dot left plus oh, I need an offset for the whole cloud. I missed that. Okay. So cloud x off equals random dot rand int 0 scene dot width minus cloud width. Cy off equals random dot rand int 0 comma scene dot height minus cloud height. And so this establishes how large my cloud is. This says how far it is from the left-hand side and the top of the scene. And then, so this creates a bounding box somewhere inside the scene. Let's say it creates a box right there. I know that's kind of a weird way to do it. I didn't realize clicking was going to create a box for me. And so in that case, if this is the bounding box shown here, all of that math keeps the ellipses inside of this little box. Okay, that's what all of this mess down here is doing. So scene left plus cx off plus ex off. So that's our left-hand side. Scene dot top plus cy off plus ey off. Okay. So that's our top. Now we've got to do the right. Scene dot right. Scene dot left plus cx off plus ex off plus e width. And these lines are going to get too long, so I'm going to break that one there too, so that we've got this is left, this is top, this is right. Now this is going to be bottom. Scene dot top plus cy off plus ey off plus e height. And then it's going to be fill equals oh dear. Do we have a Python arithmetic shift left? Okay, so we have the left. All right. In order to build a number like this, you have to do bit shifting, which you may not have talked about at all. So I'm going to write a function to create a gray shade using color, which we calculated. Fill, and then it was outline color, was that? Outline, yeah. And so outline equals gray shade color. So the outline is the same color as the interior part of the cloud. So now I need to make def gray shade. We'll just call this a level. In order to make a gray, we want red, green, and blue all to be the same level. So I'm going to return level shifted left 16 bits plus level shifted left 8 bits plus level. And if that doesn't make any sense to you, don't worry about it too much. Basically, I've created a number here somewhere close to FF, and it's as if I were shifting it into one of these 16 bits at a time. So each of these digits here is 4 bits. So there's 4, 8, 4, 8, 4, 8. And so the first one I'm shifting left 16 bits, so it ends up in this position. The second one I'm shifting left 8 bits, so it ends up in this position. The last one I'm not shifting at all, so it remains on the right hand side. So I've written a lot of code there, and I just minimized my editor, which I didn't mean to do. So let's try running this and see what happens. Huh! I got an error. Wow. That's pretty impressive. Unknown color name. Huh. Well, looks to me first like I probably need to do that. I think we're still going to get an error. Okay. Now, oh boy. Okay, this is not going well. I need to create a string. I don't need a number. And so I've been building a number here. What I really need to do is build a string. So we're going to do a format string, and we're going to say now hex equals format string how do you format a hexadecimal number in Python? Format hex number in Python. $02x%i. This is the old formatting. Well, we'll stick with that one. We can figure that out. 02x%i. Alright. So 02x percent 02x percent level print hex. Let's see if that did the right thing here. Okay, that looks right. Good. Return F. So our string needs to have this pound sign at the beginning of it, and it's going to be hex, not prim, curly. Hex, hex, hex. So Let's try that and see what that does for us. Well, that kind of looks like one cloud. Is that all that I did? That's right, because I said I was going to call draw cloud several times. So now I can say for underscore in range, let's put 6 clouds in the sky, draw cloud. So now we should be able to kill this off. Well, okay. Kind of what we wanted, except we really didn't want our clouds to be down in the ground. There's some problems with the aesthetics of the clouds too, but we'll work on that in just a minute. Why did our clouds go into the ground? CY off minus cloud. Oh. Scene height. Maybe we need a sky height. Let's do a def sky height self. And that's going to be return self.height times self.sky%. Okay. Oh, come on. Now I can come down here, and instead of having my y off be height, it should be scene.sky height, which is really what this is right here. Sky height. So let's try that first. Whoops. What's the problem? Non-integer stop for rand range. Probably sky height. Where did I use sky height? There it is. So sky height, I really want it to be an integer. Where did I define? Okay. Return int of that. Okay, let's try that. Okay, now these are starting to look a little bit better. These look good. These are kind of squished this way. So I want to make sure, I kind of want my clouds to be wider and maybe bigger. So let's make the height be uniform 0.1 to 0.6. So that means times E. No, not. I'm fixing the wrong one here. It's cloud height. I want to be smaller than the width. So I'm going to say random.uniform 0.1 to 0.6 times cloud width. And we'll turn that into an integer too. Let's see what that gets us. Okay, it's still not beautiful. Maybe I shouldn't have gone as low as 0.1 because these are too squished. So let's make that 0.3, and maybe this goes high as 0.75. Okay, And it looks like some of my clouds overlap, but we can cope with that. But those look kind of like clouds. They may not be quite as cloudy as his clouds, but it's a step in the right direction. So, okay, a lot of shuffling around there, but again, you've seen how I look up things that I need. I know that creating these colors seems a little bit bizarre. I'm trying to think of a good way to describe it. Better than what I've done so far, and haven't really come up with anything. But if you futz around with this a little bit and creating colors, maybe you can see how these relate to each other. And I could make them be down to a little bit darker by lowering that number there, for example. There's that. So that allows a little bit darker things inside of my clouds. Obviously, I've allowed my clouds to get really small, which perhaps I didn't want to happen. But hopefully that at least gives you some things to work from. And I see, when he says ground, well, no, he's got ground there behind his grass, doesn't he? Okay, so I'm going to have to do some draw grass and things for next week, but this at least gives us a little something to work with. And I hope it wasn't too confusing, and I hope it's useful, and appreciate you watching.